Learning things and we're building our skill set. So don't be afraid to ask questions and engage with the content, and know that we're here to all help each other grow the community and grow not only the community but the tool sets involved with the community. And we'll get to what ApeWorks has to do with that a little bit later in the session. So anyone that's here today, has anybody written smart contracts before? Okay, anybody deployed to mainnet? Everybody got verified contracts? So then you're part of this chart, right? If you're a verified contract on mainnet and you've written a smart contract, and one of the things that we can see is, even though there may be somewhat of a what they call a bearish market, although we're coming back, right? What we tend to see happen in the statistics is that when the kind of speculation goes down, right, like the price kind of goes down, there's a reinvestment in the technology. So people get kind of like, well, now that there's not so much hype around a price, let me like engage with the actual tech, learn some more things, find out some cool stuff, and then we see people coming into the marketplace through the technology, right? So you all are in the right place is basically what I'm saying. So your next question is, okay, well, what is Vyper? Vyper is a contract-oriented Pythonic programming language that targets the EVM, Ethereum Virtual Machine. And some of the things that are unique about Vyper, and we'll get into more depth about this, is this focus on security. That with security in mind, it should be possible, and not only possible, but natural to write secure contracts, right? We shouldn't have to be like, check your code, right? Like, duh. Let's run some tests, let's check our code. But let's try not to introduce vulnerabilities or flaws through the language itself, right? So these can, we'll get into more depth here, but the language should be sufficient enough that unless you are trying to do something malicious, you're not accidentally doing something malicious, right? Also, there's simplicity around the language and the compiler itself. There should be a simple implementation that means that you can look at and understand what's going on. It's easy to read, it's easy to understand the implementation, which gets us into the auditability of it, right? So anybody here been through a contract audit yet? I see at least one head, okay? So you're gonna eventually, if you're putting contracts out there and you're getting hundreds, thousands, millions, billions of dollars running through those contracts, you probably need somebody looking over your shoulder saying like, is this money secure? Is this money okay, right? So when you go in to have your contract audited, the code should probably be pretty easy to read and understand. With that in mind, Vyper was implemented in such a way that it's actually easier to read than it might be to write. Not to say that you can't write it easily, but that through being able to read it and understand intelligently what's happening in the contract, there's not kind of this misleading code or having to jump around between multiple contracts, right? It should be easy to read and understand, which therefore means that someone that doesn't have a PhD in compiler languages should be able to sit down and understand what's happening with the code. So I'm sure that if you've already written some contracts and you're here today, you've probably used Solidity before. A couple high-level things comparing the two languages. Solidity was first proposed in 2014. I think it was like August 2014. Statically typed language. ECMA script-like syntax, which basically means it's kind of like JavaScript in writing with the brackets and such. And it's considered a Turing Complete language, meaning that you can infinitely loop, right? Vyper, on the other hand, was a kind of research-based originally language in 2018, strongly typed, derived from Python, and it is non-Turing Complete. And you're saying, okay, what's up with this Turing completeness? Why does that even matter, right? And when you think about the EVM, the virtual machine itself is non-Turing complete. So you're like, well, what's that about? Let's see, why are my slides not? Okay, so why Turing incomplete? This is actually a quote I got last night from Fubalubu. If you all look back on contributions to Vyper, I think you'll understand who that is and maybe what role that person plays. But the concept here was, let's constrain the language because the underlying technology is also constrained, and let's make that the forefront of what coders are thinking about when they're coding these contracts. Is you want to be gas-minded, right? Like for financial sake, but also like what happens when you just have a contract that keeps executing in a loop and there's no way to get out of it. So what are all the possible states within a state machine, and you know, what are these outcomes? So you want to be able to test against that. You want to write safer code, and the constraints actually become features to you, right? When we think about if I tell you to paint a picture and I give you an infinite amount of colors and an infinite amount of tools, sometimes people actually get stuck, right? Creativity is sometimes better engaged and reinforced by the limitations that we put by saying, okay, paint me a picture, but you can only use 2 colors of blue and a red, right? Your mind already starts coming up with these things. So this is almost part of a feature set, right? So you say, well, security, what does that mean? Let's see what that looks like. So your contracts naturally will have ways of kind of falling back or gracefully failing, right? If you start to have an attack, you want your contract, you want the ability to be able to kill that contract, return the money from it, or you want scenarios where you want to provide funds to others. And these are naturally occurring events within your contract, but they can be exploited, right? So there's a paper that was out there, Finding the Greedy Prodigal, can't even say that word, Suicidal Contracts at Scale, that looked at contracts that were currently released on the chain and kind of put them into these 3 categories where they were very easily exploited because of issues around how the contract was written with kind of solidity in mind and some vulnerabilities that were opened up. One of those things is a suicidal contract, which means that a self-destruct instruction can be called by an arbitrary address. So imagine there's a contract out there, anybody just happens to call upon this one opcode or function, and it kills itself off, and maybe you even get to set where the funds are returned. Probably not a good idea, right? The prodigal contracts release Ether to arbitrary addresses carelessly. So when we think about how we might want to release these things, we might want to release funds back to an owner, like in the instance of a contract being destructed. Or if we are running a lottery, we might send addresses ETH that have contributed in the past. Or if we're running like a bounty program, somebody sends in a solution, you want to release funds. So it makes sense that you should be able to send an address and authorize that address to send funds. But in the prodigal contracts, in this instance, any address could just say, hey, send me some money, money was sent, right? Greedy contracts are considered contracts that are kind of like killed in that they're still alive. The initializing contract has been killed off, but there's still like a live portion of the contract that holds money. So it's either a completely dead contract that people are still sending money to and there's no way to get it out because that address is still holding funds, or the contract's alive and locked and there's no way to initialize a refund back from it or kind of securely remove it from the chain. So how are we going to fix those things? And we say, Vyper, right? So here are some of the limitations of Vypers that we will consider features. One of them is bounds and overflow checking. So anytime that you're running an array, you don't want to go past the end of the array, right? So it's actually limited. You have to specify how much of the array you're going to use. If you're going to use 1,000, then you tell it 1,000. If you're going to use 2, you tell it 2, right? Support for signed integers and decimal fixed point numbers. So instead of these approximations where we might end up with numbers behaving differently than we intend, we actually have a fixed point number there. Decidability, so we can actually determine the outcome. So this is kind of getting into that for looping situation where we can determine or compute the upper bound so that we know the top limit when we're consuming gas. That at most this contract will execute 27 times in this loop, and that's the most it could execute. It might only execute once, right? We got the strong typing. The compiler code itself is small and understandable, and we have limited support for pure functions such as constants not being allowed to change within the contract. Said it once, it shouldn't change state. Things that Vyper does not support. Once again, this is more on thinking of it almost as a feature, even though I'm telling you what you can't do. It's kind of a good thing that you can't do these things. So instead of modifiers, you all have seen maybe like a owner only or some modifier that's written. It's generally kind of a little bit of a mix in on the code that allows certain kinds of preconditions, postconditions. By not allowing modifiers, we reduce misleading code. We can remove those preconditions, postconditions, or state changes. These become explicit in the language. We lessen the jumps within code, so when you're reading a contract, you're not having to reference multiple files or jump around within that file like you're locating labels. And the way we kind of still have these things is by using inline checks or asserts instead of doing these modifiers. We're more explicit about what's happening. Another thing that at least does not exist right now is class inheritance. So instead of having to ask, okay, which class's function is going to take precedence when we have multiple classes inheriting, right? We already know that this is the class, here it explicitly is, right? Don't allow for inline assembly. So instead of writing some assembly code and throwing it into a contract, that would obfuscate the variables. Now I don't know when I started with the variable name whether this name down here has been changed or not, right? Like it's, once again, we're going for very explicit, readable language. And we don't allow function overloading. So which one gets called? The signature with 3 items, 2 items, 4 items, right? Instead of kind of having to go through and find out which function is going to be executed, we can know that any function with that name is that function. Some more things that we don't support. I swear we're going to get into the good stuff here in a minute, but I want to at least lay the groundwork. Is this concept of, right, like the looping. So we don't allow operator overloading. So when you call like the add function, it's going to be the normal add function. Recursive calls. If we allow recursive calls, once again, we can't calculate the upper bounds of those gas limits, and this would set us up for a gas limit attack. We don't allow infinite length looping, once again, similar to recursion, which opens you up to a gas attack and also doesn't allow you to calculate the upper bound. The binary fixed point, we don't allow that, but you can do a decimal fixed point. And so when a decimal fixed point is written as a literal, then you know exactly what that number is versus an approximation with a binary fixed point. So, okay, what's this contract look like? You've told me a lot of features. Let's start getting into the code a little bit. One of the things is that one Vyper file equals one contract. So I'm not going to have multiple contracts within one file, but I can say that one file is a contract, okay? You can set the version pragma similar to you see in Solidity. It uses the NPM style syntax where we start with like the hash at version, and I believe the current version is 0.3.3. The state variables here are permanently stored in contract storage, declared outside the body of any function, and they can contain the default value for their type, and they're accessible by the self object. So at any point you can call, like self.greet in this situation and see hello world. Functions can be called internally or externally based upon their visibility. So whether you have the at internal or at external decorators, we'll look at it in a moment. And they accept input args and return variables. Events are interfaces for logging events, and they can be indexed so that they're searchable. Interfaces are the set of functions defined for all externally available functions. I need to maybe consider fixing that up a little bit, but they can be added inline or imported from a separate file. So I think the larger project that we're going to look at in just a little bit calls to an external Vyper contract within it. You'll see the import. We'll go through that a little bit. And then structs allow you to define custom types. Decorators, yay! All functions must have a visibility decorator, so they're either external or internal. Obviously, external can only be called externally. Internal can be called within the current contract. Pure doesn't read a state or environment variable. View does not alter state, and payable is what allows to receive ether, right? So if you, and the thing is, these can't be mixed, right? In certain ways, like they become exclusive. So if you say something is payable and also pure, that doesn't make sense, right? Like you're sending money, but then it's not going to read the state and it's not going to change the environment, right? So those things would block each other. And then non-reentrant means that it cannot be called back into during a external call. So one and done. All right. That's a lot of high-level learning. So you might be saying, where can I find some of these resources? Obviously, the Vyper documentation is a great place to start. There's some examples here on Vyper examples. There's the Vyper repository itself, which has a lot of example code. And then here's where we start getting into why I'm from ApeWorks and what Ape has to do with Vyper, is that ApeWorks is a development tool for writing smart contracts, which heavily supports Vyper. And one of our main things that came out just in June is actually the Ape Academy, which has video tutorials and walkthroughs around Vyper contracts. So might take just a second here to see what old Alex has got on the Academy. Make this a little larger. Is that too big? Is that good? So here's the Ape Academy, and I'll be using this tool today as a part of showing you how to compile contracts and how to test contracts. So anytime that you need to reference that stuff, obviously we've got like a getting started guide here. Said there are videos, YouTube videos on it, as well as walkthroughs. So some good content there. And the project that we'll be working on today, or I'll be walking you through, is an ERC20 token. And we'll get a little more into depth with that. But actually, Chris here was the writer. Is that right? How do you want to specify that? The creator of the ERC20 walkthrough that is on the web there. All right, so in terms of installing and compiling Vyper, for pure installation of Vyper, there's Docker image you can find on their website. You can use pip or nix. You can obviously use ape with the ape Vyper plugin. And then for compiling, if you're just wanting to play around with it online, you don't want to commit to a tooling just yet, Etherscan actually has a compiler for Vyper. Also, the Remix online compiler has like a plugin that you have to like activate, or you can obviously use our tool. And if you're doing command line, there's some like command line ways of compiling code. So I wanted to, I don't know if this will capture it or not. We'll try it. So we saw like the, you know, the traditional, how do I want to do this? Oh, no. Oh, EU, that's fine. Right, quit. Demo.py. Okay. So I have Vyper installed, and I can say, oh, I'm not in my, okay. Pyenv. Demo. Let's try that again. All right, so that little bit of Hello World code we saw earlier, this is just downloading Vyper and using it to compile. I can now see the Hello World. This is the bytecode that you would actually, right, send. And then if I want something like the ABI, can actually see the ABI of it here. But obviously this is a little harder to work with, so that's why I want to show you all APE a little bit, because it's like, all right, now how do I test it, right? Like, how do I get a little more in depth with it? So a quick video here of installing APE. I swear it really doesn't take that long. I probably should have just done it by hand. APE is pip install eth-ape. We'll download everything. Successfully installed. This is an older video. I think we're on 3.5 now. But I wanted to highlight some of the things that you get out of the box with APE is management of your accounts. Here's where you can compile. You get an interactive console. So if you're used to working with Python, you can kind of already, all those tools are available. So the Pythonic nature of Vyper, along with our tool set, means that you can kind of keep that same mindset while you're working through. You can switch, we've got multiple networks, and because it's a plugin architecture, you can actually write your own plugins, quite easy to do, so that you can keep using the tools you're used to. We already support, through our custom plugins, things like Alchemy and Fura, Hardhat, different ecosystems like Phantom or BSC. So there's that, and then you can actually run Python scripts or run this test suite which utilizes PyTest. So, oops, why did I click that? So what I would like to show you next is another thing that Chris here has worked on, which is something we call Ape Template, and this creates a template project for you in Vyper. So you basically just install Ape Template plugin, and then you can, right now we've got two things to choose between, the ERC20 token or the 721 NFT. It meets the standards and interfaces for both of those, and it creates this structure that we see here on the right-hand side. I'll kind of dive into more of that in a moment. Everybody's good, comfortable with what a ERC20 is versus a 721? Okay. Super quick, 20 being like the same identical token, 721 the NFT having like special metadata associated with it, just for the video if nothing else. And so if we want to see how installing template looks, we just can say once Ape is installed, Ape plugins install template. And I think we're still on 3.0 there. And then I can point Ape template to the GitHub repository where the ERC20 token exists. I can give that a name for the token, for the project, give it a symbol. Anything that I don't wish to change will default to the brackets that we see in the left-hand side there. So this is a feature of Ape template that utilizes cookie cutter. But one of the other reasons that this is really neat is that when we look at the tests folder that's created here, we're actually going to see that a lot of tests are already created for you around common functionality of that token. So let me switch back over. One day I'll learn how to work the computer, y'all. So I'll do that again, just, I've already got it installed. I can say, all right, make me this template. And since I've already run it once, it actually caches that GitHub. So this could be the GitHub link directly, or this kind of shorthand for GitHub. And I'll go ahead and re-download it. Anybody want something other than demo, or stick with demo? Stick with demo, okay. And then I'll just save the rest. These other features here, right, give you some customizability around your token. So feel free to play with those, turn them on and off, and it should turn on and off the associated tests for them as well. But We can now see that those files are there, and I will go ahead and open this in VS Code maybe. We'll see how small VS Code can be. I know, let's see here. Is that okay for everybody?
Yes.
All right. So here's our Python Vyper script contract. You guys got to keep me straight here. I mean, like, really, you got to point the incorrect information out. So we see the name that I gave the token, the symbol associated with it, decimals. And Chris, you got any quick info on some of this stuff?
Yeah, so all of that, what you just put in, has been...
I'll get closer to you because we're on mic. Sorry.
Come to you. So all of this is built with a cookie cutter. So it's what we just did in a terminal was customization of this project. And if you just make everything default, you can literally compile as is and then throw it on a test net. And so when you're ready to make it yours, you can just be ready to throw it in mainnet or whatever you want to play with until you are comfortable with it. And so if you actually follow along with the Academy website, once you deploy it, I tell you what each method means and why it's important through the standardization. So if you're still beginning to learn how to use this or don't know anything about smart contracts at all, I tell you what it means and why it's important in the standardization.
Thank you, Chris. So as promised, let's look at the test here for a moment, and then by the end we will actually deploy this contract. Won't do very much for us because we've not put any custom functionality into it, but we actually can see it on a test net. So the tests that come out of the box here are, like we said, PyTest. You can use anything that's already associated with PyTest, create your own custom fixtures here. So I mentioned like being able to import the other Vyper contracts. Here's the 712 contract. We see it imported up here, creating a fixture around it, and that's for permit functionality. We've got a fixture here based in Ape around the accounts. So out of the box, you get 10 test accounts that are already funded that allow you to play with your contracts locally. So these fixtures here for like an owner or receiver, and then this is calling like the deploy functionality on the token to kind of get you that like local testing environment where you have the deployed contract. And then we're able to see a test against like the initial state to make sure, okay, did these things actually get set? Checking your balances, supplies, looking at transfer functionality, like if I want to transfer things, does it actually transfer? Are they getting the correct amounts? Then we've got tests for the approval process, minting, burning, and then a test for permit that works on a non-local chain. We're currently updating some of the tests around that, so it's skipped for the moment. But if I just go into my environment and I run ape test, we'll see that it compiles and runs those tests with the last one being skipped. Passes all of our tests. So please feel free to pull that down. Another step that might be required, I had already installed this, but it would be the pip install -r requirements.txt, and that will install the Vyper, this EIP 712. All right, so let's interactively call like ape console real quick, passing the network flag, and
So
what network should we?
What is ape console actually?
Do you want to tell them what ape console is while I write it?
Yeah, so this is one way to interact with all your methods and make sure it like works.
I better not use main.
And so what he's doing right now is trying to make it into a local test net or whatever network you're comfortable with. And another good point with this project building is like the difference between like Wizard and OpenZeppelin is the fact that they'll do the entire project and also give you test methods.
Trying to remember.
Because with the contract with OpenZeppelin Wizard, it only gives you that contract, but you don't really know what to do with it unless you understand the architecture behind it. So this is a really key point that we're trying to make sure that people who don't understand this architecture would be comfortable using. So this is what we're trying to focus on here. And so he is deploying an account. And I'm trying to...
it's where I forgot to add any token to that account.
Yeah.
Let me try that again, because I need to go to the test net, or not test net. There we go.
Yep.
Come on. Ah. Nope. We're getting there. This is why I film ahead of time, because I get nervous and then I hit all the keys.
Yeah, so this account test will actually give you some funds and...
I need to go to Infura and load. Apologies, I need to load tokens, but this would work.
Yeah.
But I do think if I can get on the right net. How are we doing on time?
It is 12:16.
Okay. If I can get on the right account, I can do ape run. Is it deploy?
Yes.
Ethereum.
How about we show them also the list of networks when we do a network so you can see?
Yeah. My computer's freezing right now.
Yeah.
There it goes. Do I have Alchemy installed?
Okay. Try it.
Nope.
Yeah, so you can see if you want to do the Dash network, you have a bunch of them there. And if you install more plugins, you can see more networks associated with Alchemy or Infura. And
Networks S.
Yes.
I swear it's the nerves, y'all.
Yeah,
Okay.
So this is quite powerful for us to see for a developer. As you can see, guys, we have under Ethereum, we have mainnet, Ops, and Kovan, and all the other stuff. But if you install Alchemy, you can get all the other ones. If you install Optimism, you get all the other ones. So most of these plugins are built with other contributors because we're open source. And if we don't have a specific network which we have, then we can help you try and build it. So
Yeah. Apologies. I'm having some.
yeah.
But yeah, so I've only got like Infura template and Vyper actually currently installed in this particular environment for the demo, but quite a few other plugins. And if I can remember the right ape run, we can get it deployed. So if you want to tell a little bit more while I try to get the...
Yeah, so we're looking at, so this ERC20 token, it's pretty strong with the fact that we have testing templates, and if you don't want to test a specific method, you say no to it, and it will actually take out the test method and all the other methods within the contract. So just build it, and we're also, once we finish with this talk, we'll be downstairs to hold office hours, so actually just come up to talk to us if it doesn't work, which I expect, because we'll just be down there to help figure it out with you guys, because we love helping out. So were there any other questions with this? Yeah.
I was curious, you had talked about Vyper being non-Turing complete.
Okay.
Yes.
Is that also restricted with like raw calls? Like if you raw call your own, like with recursion, if you raw called your own function, is that restricted as well?
So I'm gonna take a chance at answering this question, but I may be wrong. So I'm going to say, please, like, once again, November, let me just remind you. But I believe there's a limitation on the EVM itself about a certain amount of recursion that it will allow. So that's part of the like conflict between a language that does allow for an infinite amount of looping versus a machine that's not intended to infinitely loop. And so I heavily encourage you to ask those questions in like the, that's the other thing I need to probably get to, is the, there's a Discord.
And also a Telegram with Vyper and all of our developers. So a lot of people are excited to talk about it, and we have a pretty strong community. In fact, that we can come talk to you online. So if you're also watching it online, so we can come say hello, and we'll come help you out.
My computer is very unhappy. It is freezing in weird ways. Let's see. Where did my...
So we're just, before we run out of time, we can just move on.
There it is. Yeah, trying to... I can show you later when I remember what the thing is. Oh, here's just some random things real quick. The original Vyper was with an I, but was getting confused with some other products with the Vyper with an I. It was part of the Vitalik had a huge role in starting the original Vyper, and then it kind of became more of a community effort, and I believe kind of stepped away from it. First production app that was written in Vyper, Uniswap v1, was actually all Vyper. Currently used by Curve, Yearn, Lido, and the first iteration of the ETH 2.0 deposit contract was actually in Vyper. So it's a growing language. We're still wanting lots of contributors around it, lots of input, and yeah. The other thing I mentioned, some references here that were in the slides, and then in terms of community, yeah, I was going to pull up Discord. There's one specific for this hackathon, correct?
What I'd like to do is drop all those links into it so
Yep.
you guys can all have access to it. I just took a picture, but I know that's not.
Yeah.
We'll drop the link in there.
Absolutely.
And
But-
another cool thing with Academy is that a lot of our users want specific contractors or specific projects. So like they go to our Academy website and they request a tutorial. So I have about like 3 or 4 other tutorials on different types of projects that we are intending to make another template for. So if you're looking for us to build a certain thing, just request it and we'll put it on our roadmap. So
Yeah.
we're to doing that with you guys.
But yeah, there's the chat. So this one is for the EthCC hackathon, the Vyper volume channel here. There's also a just very specific Vyper channel. So asking the question that you had earlier, I would absolutely put it in here. This person, the Big Tech Sucks, is a major contributor for Vyper, and then yeah, and then of course Ape Academy, or not Ape Academy, but ApeWorks, which is the company I work for. Here's our general, community there, and I believe, Chris, did you name the? It's a little hard to see, but Competitively Dumb Questions is a great place, especially if you're starting. And feel free to ask anything from very low level to very high level questions. Right?
And if we have bugs or problems, just post it there and complain to us.
Yes.
Yeah.
Sounds good.
Just know we're all growing, right? We're all growing and learning. So I appreciate you all being here today, taking the time, and welcome to Vyper.
Thank you.
Thank you all.